Yeah, thank you. Thank you all for attending this. So, uh, as the agenda is there, we'll start up with the Simscape. Many of you might already be using Simscape and be quite familiar and using multi-domain physical modeling with that. So here I'm going to explore very few fundamentals because there are a lot many people who may not be aware of physical modeling within MATLAB. Of course, there are other specialized tools within other softwares like maybe Siemens, AMSIM, or even other kinds of stuff where you can do more detailed modeling. But I personally uh, kind of love MATLAB because it has multiple domains put up together. So you need not worry about integrating multiple platforms. For example, you need a deep learning, you need not search for Python, TensorFlow, PyTorch, etc. when you want to do something on your vehicle dynamic stuff. And you want to do something on CAD modeling, again, you need not jump anywhere because Simscape is there to help us. So kinds of, I love that because there are multiple things you can work on the same platform and it saves a lot of time. So that's about the introduction. Now let's get started. So what we see here is basically many might have all recognized from this schematic that it is basically a quarter car, or you can call a double mass spring damper. So the advantage of Simscape is for researchers and for engineers. The good news is you don't have to model anything with equations because equations for each of them is already modeled inside. And what we care from the user side is only the schematic diagram. So if you are intuitive enough, but for some reason maybe bored or lazy or to derive equations of your system, Simscape is there to help us. So the way it is arranged is very simple. You have two systems of springs and dampers and two masses, and they are arranged uh, connected one to other. So for each of these domains, so Simscape has multiple domains. If you go to the library browser under the Simscape, QRS, so you have a lot of domains, and each of them come with a very big library of each of the blocks that you probably can think of using them. So I've just built this using those library blocks. You have also the option to build your own libraries, maybe of a different domain completely altogether, or within the same domain for multiple blocks that you may not find directly. So there are options for that, and MATLAB is cool about providing a lot of options for the end users. So coming to this model, I have this part called the tire. I have modeled the tire as a linear spring and a linear damper, and a small unsprung mass because the tire and suspension also has mass, so a mass accounting for that. And the unsprung mass where actually you sit. This is the suspension, and the unsprung mass where you actually sit. The input to the ground, the inputs to the Simscape are basically of two types. The first one I'm going to discuss here. The other two, I mean the uh, demarcation between both of them becomes clear as we proceed further. So here I'm giving my road input using this ideal translational velocity source block. So this is how we give inputs to the system. So we need to also include gravity. So this is a diagram-based 2D modeling. So basically, there is no directly available gravity option. So just multiply the mass by the g force and you directly get the gravity on top. So this is only in, you can call it as not all dimensions. That's only limited on dimensions. So let's simulate and check how does this look. So I get up the simulation results explorer. I have this plane model and I see my spring deflecting because I gave some input and initially it started from this. So it has fell down, it has settled, and then I give a road input and then the spring again oscillates. So that's cool. But can we take this another step ahead? Because we have modeled this as a springle mass, spring and damper. But if you're really into designing, you would very easily understand that this damper is not a single component. You might use hydraulic components, pneumatic components, so on. So is that possible to do? It is possible. So I have one more system.
So Krishna, just a quick question that came through. So this looks awesome. The fact that you can connect this, it seems very simple. Maybe not everyone's been exposed to it, but the question came through is, how did you even learn about this, and how did you discover this? So for many MATLAB and Simulink users, the concept of Simscape sometimes is like, where did this come from and how do you pick it up? So can you share a few words of where you first got exposed to Simscape and how you learned it?
Yes. So Simscape is not a new thing. It has been like more than a decade or even more prior to that. And this is technical terms, it is called as physical modeling. And there are even other commercial softwares available for physical modeling. Like I already discussed, there is Siemens AMC, which is very detailed in terms of the libraries. So in MATLAB, I came to know because being a vehicle dynamics, doing my PhD in vehicle dynamics, I need to model a lot of things. And I find it really time consuming to model the equations. Yeah, that is a fact. Being any engineer, you would understand that if you were uh, especially doing something on research side, because we need to do something else which is not already available. So modeling equations get difficult. Then I was searching through, then I came across AMSIM. Then I had issues with integrating because I need to develop control systems and also do a lot of machine learning stuff on that. So integrating again with MATLAB is an issue. Then I was introduced to something called Simscape. Because I was browsing through internet and I found something called Simscape already exists in MATLAB. So that was voila, whatever we require is already exist. So then I started building upon, and the interface is very simple, like any other softwares, because it is more intuitive than a programming language. MATLAB has done a great job in making it more intuitive. So you just connect the blocks one by one, make your figurative model onto the canvas, and just start simulating it. Yeah, there are more details to that, but the best way is to start building it, and you learn more. The more you start using the software, the more we learn. So that's a very small intro.
Thank you.
Yeah. So yeah, I was talking about the damper. Let's go inside this. So this is a more complex kind of a damper. So let's see what does this damper do. So if you can imagine this, you know how does a damper look like? It has one cylinder and a piston inside, and there is fluid on either side. And as soon as you apply the force, the piston traverses and the fluid changes, and that is what actually dampens. Of course, the fluid is very viscous. That is why the forces get dampened. So to model that, I have two pistons because the piston needs to move both up and down or front and rear in whichever direction you place it. So I have two pistons, and there's an orifice because the fluid is incompressible. It needs to move between both the chambers. So I have an orifice, and I have chambers, hydraulic chambers. So a few parameters to describe how detailed you want. As well, I can define my fluid properties. So these are some properties I've put. I'm sure you can get more detailed properties from the data sheets or from the manufacturers. So that shouldn't be difficult. So this is a basic hydraulic damper. And so now you need to sense how much the piston is traveling and how much the volume is getting compressed. So Simscape also has sensors. It not only the sources, but it also has sensors. So I sense how much is the motion going on, and I calculate the volumes of each of the chambers, and then I compute. Of course, Simscape automatically computes what is the volume inside and how does the fluid characteristics evolve with application of external forces, and that is all automatically done. So as you can clearly see, you see different colors. This is green, this is kind of yellowish orange, and so on, and this is pink. That is what's first difference. The second difference is you do not find any arrows anywhere. If you are using Simulink for some time, you know that all Simulink blocks, they have arrows. That is their direction. So this Simscape is bidirectional. That means the energy flows both to and from the components. So that is why you do not have any arrows. And for this region, you also have an additional solver that is there because it is bidirectional. You are using additional solver to back up some more settings for this. Now let's simulate this and check how does this move. So let's run this. Done. Now I get my hydraulic. So this is my hydraulic damper. I see the chambers, the pressures inside each of no, this is the how much the chamber is being the piston is being traveled within each chambers. Then the pressures between these chambers. Then I have my motion sensor which actually measures the velocities and position of the piston and the orifice pistons. So let's check what impact does it have on the suspension. And a spring, sorry, sprung mass. So this is how it looks. We'll compare both of them together. This sprung mass here. There is a variation because we have used the idealized one with the plain damper, and when using hydraulic, we need to tune more of the parameters because the more details you need to incorporate into your models, the more parameters you also require. So depending upon what parameters you have from the data sheet or from the manufacturers, you can choose the fidelity and you have all the desired things present. So this is one level where you have only the 2D, or you can call it maybe 1D because it's moving only in one direction. So the canvas is simple. You have only one directions of motions, and that is how you model the first kind of simulations. But often systems that we want to model are not as easy as described here. You might need to do something more complex. So how do we do that? So I'm going to browse you through some other models. So let's check this. So this little thing you see here, it is a new add-on within MATLAB 2021A. This basically provides an interface with Simscape and Simscape multibody. So what does that mean? We'll come in a few minutes. Yeah. So this is the animation that you get once you compile this model. Let's run this, and we'll see how the model works. So you must have guessed this is a catapult. Initially, its resting position is 90 degrees. So you have stretched it from there and held it here at the beginning of simulation. And as the simulation starts, you have released the pressure on that. So as you release, it just bounces and the ball bounces. So the reason I brought up this is because there are a few cool things that are new with MATLAB 2020B and 2021A. So how do you model this? Its principles are very simple. You have few blocks. If you go to the library, Simscape and Simscape multibody, you have all the required things that are required to model. The first is the bodies. We have different primitive bodies, and we can build multiple geometries from that. There are different constraints if you want to say that your body should move or shouldn't move in certain directions. Then if you want additional forces or torques or some kind of attraction or repulsive forces, maybe like magnetic or gravitational force, there are blocks for that. So each of these are dependent upon some frames, either global or reference frames. So to manipulate frames, again, you have different blocks to either to manipulate or to sense. Then the interesting point is the joints. Joints basically adds degrees of freedom to your motion. So here, basically, if you see there is 1 degree of freedom, it is rotating about this. So that is what this degree of freedom does here. Similarly, there are multiple degrees of freedom available. To help you with even more complex things, there are gears and couplings to model. And this is the cool new one with 2021A. which provides a direct interface with Simscape multibody and uh, the mechanical components of Simscape. Previously, you need to install an additional toolbox available on MATLAB file exchange called Simscape Multiphysics Multi-Library, which provides the exact same blocks here, but now you need not install any additional toolboxes directly provided. So coming to this, how do we model now? So the first starting point is these three blocks. Of course, this is optional, but it's always good to have this. You have a solver, like I already said, it's all again bidirectional. You see there are no arrow marks anywhere. Then you need to define where is your first reference frame, that is called the world frame or the inertial frame. So you put it so that becomes the reference frame. Then this is basically to define some of the configurations like the gravity and other linearization settings. So I set my gravity in -z. So the little small triad you see here, this is the global coordinates that are there, and all other coordinates are expressed with respect to this. So now I have my world frame. From world frame, so you can see here, this is the config block. Under the config, I have my world frame. My world is situated here. And with respect to this whole arm should rotate. So I have a rotational degree of freedom. It's called Revolute Joint. So I have that here. So the output of that Revolute Joint is connected to the rest of the body. So I have a hinge that is there. You can see there's a small hinge and there's a rod attached to that and a cup to hold the ball. So I have this arm. So that is this arm here. I have this cup. You can model the cup as, again, from using all the individual blocks that are there.
So Krishna, sorry, just a quick question. So this looks super awesome. So it's very cool that you're showing this, and I love the fact that you're showing how this catapult was built. But there was one question was, can you explain a little bit more on how the contacts are actually modeled here? So that's one question. And then the second question, which is maybe a follow-up on the first one that we asked earlier, is I think it comes from a professor or a teacher who's joining the session, and he's asking, how do you inspire people to use this technology and discover it? So how can you expand and share this with others? Because it's the simple example of the catapult seems very interesting, but is this how you trigger other people to use Simscape and discover it? Or maybe you can share a few words of how you inspire others with these simple little examples. But there are two questions. How did you model the context? And then it's more of how do you get others to embrace this technology, which seems so simple from what you're showing here?
Yeah, actually, both of them are quite related. It's the split up, but so the motivation comes from starting to model the real world things, then we can go for other complex things. So some of you who might be joining are from automotive engineers, so I thought I could directly jump and show up a car or a motorcycle, but that wouldn't interest most of the other participants. So I thought, okay, let's make a simple model which everybody can relate to, and which also should include all other components like why it is being used and how do we model such kind of simple things. So there are many things which we see, but which you see in our day-to-day life, which are basically the physical models. So translating them into software is a pain for many students. I think most of you would agree to that. So that is where these tools like Simscape, which are actually fun to do with, and that is what Gareth has very gracefully put up the session's agenda as. Those who are bored at home with the COVID lockdown, just come and join us with us here. We can get rid of some of your boredom and maybe do some fun stuff. So does that answer?
Yes, thank you. Thank you.
Yeah. So I'm here. I'm not trying to explain everything in more details because I guess you can find more details. But I just want to brush you through what are all the capabilities that Simscape can do, and maybe give you some inspiration to not to panic with your courses for the engineers and students, and for the others to make you life more easier or more fun with using cool softwares that are at our disposal. So yeah, coming back, this little block that you see here is also a new addition with MATLAB 2020B. This is called the spatial contact block. So basically, previously, if you want to model any contacts, you need to quite struggle a lot. And there has been toolboxes on MATLAB File Exchange by MATLAB staff, basically called Simscape Contact Forces Library, where there are predefined sets like a plane to a ball, or a cylinder with a ball, or cylinder with a plane. So there are few predetermined stuff that is already available, and you can pick and place and match with your requirement. It's a big, I could call, maybe at least from my side, it is kind of a headache to figure out the surfaces and then place each joint at or each contact each one. But this is a very cool place where each of the blocks, they come with a separate port. I'll show this. So this is a small option called export geometry. So the whole geometry gets exported through this port. So that is why you see it's a dashed line. All other lines are solid gray, but this is a dashed line. So the geometry exposed, and the contact block takes in those geometries only. Now it works based upon a small penalty that is put when the contact is made, and you can determine the stiffness and linear damping within this block here. If you are having any nonlinear stiffness and damping, you still have the opportunity to do that. You can sense the whenever they hit each other and add additional external forces and torque blocks to add whatever is the forces and torques that you want to compute nonlinearly and add. So this is a very nice addition that I personally like with the new additions because it makes contact modeling much simpler. And as you see here, so initially the ball is inside, it is resting because it is touching the plate at the bottom. So there are 4 plates here and it's touching one of them at the bottom. So that's why it's resting there. So Simulink users might be aware of buses in Simulink. Similarly, there's a bus in Simscape. So using that, I put up all these 5 bars that are there and took them out with the Simscape bus, and again I'm delinking them, adding them to this ball, and I want this ball to move freely in space with all 6 degrees of freedom. So I put 6 degree of freedom joint. So basically it is 3 translational and 3 rotational. So it's just free to move anywhere. And also I have an external box because I assume that you are trying to play a dart game. And instead of dart, you have this ball and you want to hit it at some point. Maybe you mark the bullseye and you want to hit it. So whenever you hit, the ball should also bounce. So again, I have the walls modeled again as the same thing, of course, but with the bigger dimensions. So I have this bus again bringing up all the geometry exporter connected to the ball again. So you see that's why it is branching into 2. And again, I put the contact here. So it's very simple. If you are good at intuition, just build the model very intuitively. You have 1 degree of freedom of joint here, about which the hinge rotates. To create a hinge, of course, this hinge does not play a major role because it's just for visual that you have a hinge here. Then you have an arm and then a ball and a holder to hold the ball, and then 4 walls plus a bottom surface. I'm leaving the top 3 because you might want to jump out of it. Now, since MATLAB is very good at its managing variables, so all of this can be managed directly by different variables. So I just give random numbers here for the different position dynamics involved. So coming to again Simscape, I am telling that this joint cannot move fully independently. It has been constrained because this vertical is its limit and it has been stretched here. Whenever it hits, it should bounce off that vertical limit. So I have a hard stop here. So I say that my bound, again, it's a random number because I want to have multiple variations. So I'm giving stiffness and damping when it hits that limit. Now I'm stretching the catapult basically. So it should have some, again, spring and damping coefficient. So I have this torsional spring and damper as a single block already modeled together. So I select this. I have again stiffness and damping coefficients. You can also put hard stuffs here, but I just wanted to put it separate so things get clear at the first glance. Now, all of this plays an important role when it comes to the initial conditions. So initially, if you see the frames, uh, so both the base and follower, that means the input and output are parallel, or they are at the same point. That is at the initial stage, but I'm telling that it is stretched. So I have basically stretched it by 90 degrees and then I'm leaving. That is what this initial condition says. So that is what I simulate now. It just bounces off. The same thing again, you can see the results. I have this Revolute joint here. You can see it has fell from that point because yeah, this measuring is a bit different. If you're giving a position, this is basically measuring from here, but the dynamics are put up in this damper. So if you want to measure with respect to this, you might have to use a Simscape sensor here and with initial condition of 90. So it just bounces off from here and it hits that and you can see the dynamics very well. You change the characteristics within here, it will change. That's a very, very simple model that you can build up.
So Krishna, and a question that came through is, you say it's very simple, but it looks simple once it's done. I'm assuming there's an iterative process to get here. Can you maybe share some of your war stories of how you figure out if this is right or wrong? Like when you push the play and the simulation button now, how do you mentally validate if this is right or wrong? What is your process? Because I think that is a fundamental element of picking up Simscape.
Exactly. So the whole of Simscape and Simscape multibody, both of them together, they are based upon intuition, especially the Simscape multibody. So you have a mental image how your system looks like. Forget about the equations. We are not worried about the equations. We are all engineers, so equations are already written for us. That's on a lighter note. Basically, you need to derive them. So if you're by intuition, we know how a catapult looks like. You have a rod, you need to stretch it, and it should bounce back. So what are all you need to intuitively? What elements do you require? Of course, you require the blocks. Then, if you go into more into theory of mechanics and other things, the degrees of freedom may sound a bit scary to some of the mechanical engineers may present here. But let's not take the technical word of degrees of freedom, but let's take it as a layman's language. How should the system behave? You know that it should rotate. So just browse for what are the available options that are there in the joints and where it should rotate. Select different frames. So one common thing where people do a lot of mistakes with frames is, for example, you have one frame here and the cup needs to be attached here at this fag end. And if you look at the library of different blocks that are available, you see the frame is only one single frame, which is at the center of geometry. So to transform it, you might have to use this transform blocks. But again, being on the more intuitive side, because that is what is the main theme of today. If you go inside this, there are options to create frames on this body directly. So I know my joint should be here and my cup should be there. So I add different frames directly on top of this body instead of creating and moving the frames here and there and trying to mess up things. Think more intuitively. You have frames here. I know I want to have a joint here and a cup here, so I add based upon intuition. And again, intuition says the joint is not freely movable. You have some dynamics to be modeled there. Either you can give an additional torque, maybe by using a motor. So that is why I have here torque source. If you're not giving that, just give it as 0. That is okay. Or you also know that when you stretch something, it has to rebound. So you have some dynamics for rebounds. Now contact has also become more simple. You need not worry about different contact points. You just have this one block called the spatial contact, which makes again things much simpler for us. So I do understand that at the beginning it is difficult. It was difficult for me also, and I guess it was difficult even for the developers to come with such a thing. So that is it is keeping on evolving over time. But the fact is, or the lighter note is, as we start building very simple things, maybe I can uh, upload if a suitable platform appears. So you can figure out that. You can just look at the basic examples, and also MATLAB has tons of only pre-built examples which helps you build up your own skills for using this, which helps you quickly get started with. But the basic thing that I would stress upon is the intuition only. If you are good at intuition, theory does not matter, because I'm not a mechanical engineer and I have designed many things only by intuition. So to be more honest, of course I design other things also, but this is more intuitively done than going more of theory and struggling out.
So Krishna, thank you for your honesty. I think that is a good answer.
Yeah.
I think it's an iterative process, but thank you for your honesty. Just maybe while I've got your attention, there were a couple of questions that came through which I think are correlated to what you're showing. One is there's someone from the audience who's a pure MATLAB user, and he's asking the question, or he or she is asking the question of how can I use MATLAB to interact with this model? Can I set and tune parameters? Is that possible to do it during simulations? How do I configure hard stops? And how do I export the results of these simulations to analyze them? Can you maybe share a few quick words of that?
Yeah. So MATLAB and Simulink, again, is very good at managing variables. So any of the blocks you touch, you can use MATLAB variables directly. So you have rigid block here. This I can put it as variable. So maybe this is some variable I have defined in workspace. I can just put it up here. It will take it up. So similarly, there are even all of these are directly customizable. But one thing to note with Simscape is, I guess many of you might know, there's a fast restart option here. So when you put it on fast restart, typically in Simulink, you can change variables, but with Simscape, there's an additional setting. So if you observe here, I have compile time put up here by default, which means if you're on fast restart, you cannot change the variables. So once you have put it up here and it's on fast restart, even if you change the variable value in the workspace, it does not reflect here. But you can change it to runtime. So then you can again access the changes in the variables directly. So any block that you touch, they are directly variable, and all the variables are can be set up. So even within the bodies, you have the variables set with cross sections everywhere. And all these variables are fully functional with all other apps. Maybe some of you might know Simulink design optimization, where you typically try to do response optimization, parameter estimation, sensitivity analysis, so on. So all of this are fully capable of utilizing those apps. And to tune these variables or the parameters, the stiffness damping, and so on, you could use one of such apps, maybe response optimization, to check how much is the damping, in how much time it settles, or how much the rebound force that you can have. So all those things that you can tune automatically. Again, manually you can try, but if you want to be on more on a cooler side, you can use the all built-in apps.
Thank you, Krishna. So maybe just another question. So sorry to interrupt you, keep you in, but there are lots of questions coming through. This is good. There's a MATLABber who is asking, saying, can I do all of these models that you're showing in basic Simulink without Simscape? So the MATLABber is talking about, well, what happens if I don't have Simscape? Can I still model what you're showing here? Yes or no? And I guess the question is, why should I invest or learn in Simscape? Maybe you can make that a little bit clearer.
Great. So this is a simple model. So you might be tempted, why should I learn in a completely different modeling scenario? But imagine you are going on a complex situation. For example, I'll just close this. We'll go back to our same mass spring damper. I love that. Modeling this part with in Simulink is easy. So just to give an equation, don't get afraid. It is mx double dot plus kx plus cx dot is equal to 0. That is what is this. It is simple. When you have two masses, two springs, and two dampers, things get quite complicated. You need 4 equations. I mean, when you split up. So that means you need to rederive all the equations. What if I say you need to add 2 more systems on top of it? Rederiving is a pain. With Simscape, it is as easy as our old friend, which is Control C, Control V. That means I can just copy this. Okay. Copy and paste. You're good to go. So how much time does it take? Just take 3 seconds to increase the complexity. If you were to rederive these equations, I'm sure you would might have some nightmares for this model. But if you have even more complex models, then it would be even more difficult. So this example, I think, should summarize why Simscape is required.
Yeah, very good. That's very clear. Thank you. And maybe just so you know, for your information, Krishna, there's a MATLABber who saw your 3D Pong video and is a little curious of how and what it takes. So maybe if you can reserve some time in your talk to show that. It doesn't have to be now, but I just wanted to let you know that you've got a MATLABber who really liked your 3D Pong video on LinkedIn.
Sure, I would just open that right away. Yeah, so it looks very simple. You see only 1, 2, 3, 4, 5 blocks here. But again, if you were to derive the equations, I'm sure you would have to struggle with that. So the way this is modeled is again the same principles that we have seen earlier. Intuitively, just okay. Now from the image, intuition should get clear. I have my bounding walls. I want this ball to move freely within this plane. So if you look in this coordinates, it is y and z plane basically. And I want this striker to move in y-axis alone. So that is what my basic intuition tells me. And whenever it hits any of these walls, it should bounce back. So you need to define some contact. So again, I define this 3 individual bodies. I go inside this. I have 3, all of these modeled here together. Of course, I have a 4th one, but I'm not using it, so I just made it transparent. Now I have this striker. Again, it's the same thing, same block, no difference at all, just copy paste everywhere. Now to move the controller, I have a degree of freedom. And now I have, okay, some of you might be aware of dashboard blocks in Simulink. So the same dashboard blocks will also work here. So using this dashboard, I can move this striker left and right. Coming to the ball has 6 degrees of freedom. That is what I've given here. But again, it is constrained. I'm not allowing it to move in and out of this plane of the screen. That means basically I'm restricting on X. But it can rotate freely because ball can rotate. There's no problem on that. I just do not want it to go out of the floor. That's all. So that is restricted. Same old contact blocks here again. 1, 2, 3, and this is 4th. So 4 contact blocks. Now, if you want to play with it, you could actually play. Go here. Because you want to play it in real time. We are not superhumans to play it very fast. So I just set the pacing to 1. Again, all the variables are defined for random initialization. All are variables in MATLAB workspace. So I just start up here, and as we move here, you can actually play that.
Thank you. I'm sure this is putting a smile on multiple people around the world. So thank you for that.
Yeah. So maybe are we on time or we're exceeding time?
So maybe 5 more minutes, if you don't mind, Krishna. So
sure. So that is on fun side. Now because we have only 5 minutes, let's go on some more serious side. because I do not want to make it more only fun, because there might be some people who might really want it to use it in their research or professional sites. So let's jump into somewhat professional things. So I have this car here. Of course, it is not again fully built up here because I just wanted to show it for a demo. You can always build more details upon that. So majority of these systems are modeled again. Many of them are Simscape, some of them are Simulink. If you're familiar with Simulink vehicle dynamics blocks, that you can realize that this is a part from that block. So interfaces are very clean and simple. So again, the bodies, the same old bodies, what we have seen in Simscape multibody. I can also import CAD blocks, not only for beautification, but also for different frames and their proper dimensions as per geometries. So in both the ways, CAD helps us. Similarly, suspensions. Tires, I guess many people are worried about tires because many automotive engineers are familiar that if tires are not proper, your simulations won't go well. So I have two tire models that are there. The one here is SimCenter tire, which you could request from Siemens website. So it is very, very good, basically. If you're an education institute, you might be eligible for an academic prize. Also, this is MF eval. So it's a Simulink block, basically. So the Simulink block is available freely on MATLAB file exchange. You could easily download it. It's the Markov law. All credits to. So you can get that. And it is converted to Simscape, basically, with inspiration from Simscape vehicle templates. Again, that is also on MATLAB file exchange. So I have taken inspiration from that and made this tire block to be usable in Simscape. So I can choose whichever I want. So let's keep it for now Siemens. Similarly, I have built driver. Again, driver is, it is complex because you need to track some paths. So I have multiple drivers that are doing that. They can do a sign test, or maybe if I have predictive, you have a waypoints and you want to driver to predict those, you can predict them. And there is also one more new cool feature called pure pursuit in recent versions of MATLAB, where you give only the matrix of X and Y points, and it will give you what is the steering angle to steer away. It just gives the ideal steering angle. If your vehicle dynamics does not match that, or maybe given that input, your vehicle might topple off or something, you can actually observe those things. So maybe I'll just run about. Let's see the animation for this. It's a bit complex, so it might take 1 or 2 minutes to compile.
So maybe while it's compiling, Krishna, a question that came through. There's a person who is very passionate about MATLAB and Simulink, and they love aerodynamics and would like to have any ideas from your experience about the tool of how to use this for aerodynamics. And I guess coupled to that is what would be a good way for people to reach out to you to kind of learn more? Meaning these models you're showing, or is this on a GitHub or somewhere that other people can reuse, or would you like them to reach out to you? What would be a good way for people to kind of reach out to you and ask questions and reproduce what you're showing here?
Okay, so the first part is the aerodynamics, and there is a toolbox called aerospace block set, which has aerodynamics, detailed aerodynamics. You can use this, and you can see that there is the outputs are the forces and moments in all the directions. And Simscape has external forces and torques block, using which basically you can give any kinds of forces and torques in any directions. So you can open this, 3 forces, 3 torques, all the things basically. So you can use this, put it up here in connection with this, and you can apply all the aerodynamic forces that you want. So I think that should answer the first one. And regarding the other one, I could be reachable on LinkedIn. I think the link is already available. You could reach me on LinkedIn. I will be there to if any questions are there. But most of these things are straightforward, and MATLAB has excellent documentation. There are regular webinars that are being organized. Maybe you can sign up to one of those newsletters, and your inbox will be filled with regular webinars that are happening all over the world.
No, very good. So if I understood you correctly, you're happy to engage with people via LinkedIn, reach out to you via LinkedIn, and that would be a good way to kind of ask you questions, and you can point them there. That's very good. And I think your LinkedIn profile is on the Meetup registration page as well as the LinkedIn event. Yeah.
So I think simulation is done. People from India might recognize that although in automotive field, this is a road from Natrax Indo. So dimensions are more or less reproduced, maybe to 90% accuracy. So you have different radiuses of rings that needs to be followed, and you can generate waveforms. And all the results, you can log them. And I prefer first seeing them in Data Inspector. So I have all the Simulink joints that are there within the Simulink Data Inspector, and what are the signals that I log. Let's say I look at lateral acceleration because I'm doing a sign test here. So the G force and lateral side plays an important role in your design. Linear acceleration, AY. It's pretty good. It's 0.4 G. So we're hitting on the linear region still. We could still go more further ahead. You can do more stuff. It is not just the inputs that you can give. You can also generate waypoints using automated driving toolbox. There's an app where intuitively can build. If you want more programmatic side, it's also based upon object-oriented programming. So you can build multiples of variations with a small piece of code, and you can integrate all of them this together, and you can have your driver drive all the way along. You may not go physically because of COVID law situations, but you can drive virtually wherever you want. You can import map files and maybe build a road accordingly.
So Krishna, that looks very good. So I don't mean to interrupt you, but I think you can talk for a long amount of time on this. There are a few questions that maybe have been published. Feel free to answer them. I've posted your LinkedIn profile so everybody can connect and reach out to you. But do you mind if I cut you off here, or are there any final remarks that you would like to say to share with the audience?
Yeah, I would just take a couple of minutes because I feel that is most important when coming to any simulation softwares.
Sure.
Yeah, so the first and foremost thing is there are many example files with any software you take, and you need to validate them with your own results. So I would suggest that maybe to put it in a more conservative way, do not blindly trust any softwares. They may be good, but so the solvers are good. There's no doubt about it. But the parameters validation and so on stuff that needs to come from the end user alone. So I could give a very quick example. I won't run it. I leave it up to you. This came up recently, and it is still yet to be resolved from MATLAB side. I hope they are not angry with me for putting up on live meeting like this. Vehicle dynamics block set. You have tires. So you might think, why should I buy something from a third party like Siemens tire when tires are already available here? So I would suggest just go back, put this here, and maybe run it. You will see a lot of variations with what is expected. I mean, here I expected means it's ideally measured from an experiment, and you have gotten the parameters by a proper workflow, and you have put the same parameters within this and within this. You would find a lot of difference. So be careful about that. You might find some more things like that. So that is up to you to explore. So when you're trying to use a model, especially for your research sites or for publications, or for whatever is the reason, be sure to validate the model before jumping onto the further. The validation helps a lot. And the second one is, this a full model or even a more I mean, this I have developed even prior to something called Simscape vehicle templates has come up. So I just shown it here. But there's a very detailed models on MATLAB file extension. It's called Simscape vehicle templates, where you have passenger cars, trucks with trailers, so on. So you could have a look at that and maybe download that. And the spatial contact block that I have told previously, be very cautious. It does not directly work with CAD modes. So when you're using that, be cautious. So that is the reason for me for purposely using the primitive blocks within the Simscape only. I could have used the CAD models, but CAD models do have some issues still. I think they would be upgrading in the upcoming releases. So keep an eye on that. And that's it from my side. If you have any queries, you can post it on LinkedIn. I will be there.